So, welcome to another riveting presentation for ENGR 325 materials. This performance is brought to you by Dawson Barnes, Jay Sternino, and Mandeep Badyal. The topic discussed will be on engineered timber products. This discussion will have a brief introduction to timber products, followed by a more detailed breakdown on three specific engineered timber products, their properties, and their place in the construction industry. So, thanks for watching and hope you all enjoy.
So, why choose wood? Well, wood is a huge part of our culture and history in BC. Choosing wood supports the local economy. Wood is typical for small home construction, and wood has many architectural and structural benefits over other materials.
Okay, so why even choose engineered timber products in the first place? Well, good question. Timber is one of the most eco-friendly options available for construction, and it stores carbon in its cell structure, so it has a smaller carbon footprint than other common construction materials. It also can be replaced by planting and, with time, producing more trees. Timber is also very pleasing to look at and is widely used by architects to transform boring spaces into works of art. One underappreciated undergraduate once said that it gives you that warm feeling inside when you look at it. Because of the relative ease to harvest timber and the wealth of forests here in Canada, it is also an economical choice to choose timber and use it in construction. Timber is also comparable with other construction materials like steel and concrete when it comes to its ability to perform against tensile and compressive forces under normal loading applications.
What is engineered timber, you ask? Engineered timber is any composite or man-made wood. It is put together using an adhesive, which binds boards, strands, particles, fibers, or veneers together. There's many kinds, the typical ones being plywood, particle board, OSB, and fiberboard. However, in this presentation, we're going to look at cross-laminated timber, parallel strand lumber, and glue-laminated timber.
Okay, so the first engineered timber product we will discuss is the cross-laminated timber, also known as CLT. Not to be confused with the popular sandwich choice, chicken, lettuce, tomato. CLT is relatively new in North America and is more widely used in Europe, where it originated as a building practice. Here at UBCO, CLT can be seen at the hangar student gym as part of the wall and roof structure. So how does CLT work? Well, it gets its name, as you might guess, by the alternating cross placement of the timber pieces. There needs to be a minimum of 3 layers, and each layer is adhered together by metal fasteners and our glue adhesives. The crosswise placement of the timber pieces gives it a strong resistance to vertical and lateral loads. This reinforcement model is representative of the cell structure of trees, which are great examples of why it works so well in nature. Some of the advantages of CLT is that it can virtually be built to any size required. When it is constructed, it is usually in a controlled environment where attention to detail will ensure it meets its requirements. Also, because CLT is so adaptable, it can be built for many different types of applications. Some of the different types of applications are floor and wall panels, structural members, and trusses. The picture on the right shows how CLT is being used in some of these applications on site and how easy and quick it is to construct. CLT is perfect for multi-story buildings as well as time-sensitive projects. Now, let's take a look at Wham Bam Paralam.
The second engineered timber product we'll be looking at today is parallel strand lumber, or PSL. Parallel strand lumber is usually referred to in the industry as Paralam, which is actually the name for the proprietary Weyerhaeuser product. In Paralam, strands are laminated together in parallel with a binder, and pressure is applied while the material cures. Due to its high strength and stunning aesthetics, it is used for both structural and architectural purposes, and often both. Parallel strand lumber is made out of a variety of woods and resins based on location and final product use. In this slide, you can see a recycled portion of a Paralam beam, which was cut at an angle to the grain to reveal the internal structure, giving unique character to this piece of furniture. Here we see another example of PSL timber being used for its unique internal structure and aesthetics. Paralam beams are often used exclusively for their structural purposes, and aesthetics are left out of the picture, as seen in this photo. Sometimes, in engineering and architecture, we want the best of both worlds, both beauty and integrity. That is where Paralam really shines. Okay, now on to the technical stuff. Material properties of PSL. Parallel strand lumber is suitable for long spans, often limited only by transportation maximums of 20 meters, or 66 feet. One of the products I looked at had a Young's modulus of 150 GPa, which is around 75% of that of steel. The same product had a density of only 720 kilograms per cubic meter, about 30% of that of concrete. The product was strong in flexure, capable of handling flexure forces up to 5,000 psi, strong in tension, capable of handling tensile forces up to 3,800 psi, and strong in compression, capable of handling compression forces up to 4,600 psi. The main weakness in PSL, like other timber products, is that it is weak and shear parallel to the grain, much like wood itself.
Alright, now we'll go into glulam timber. Glulam timber is composed of layers of wood, laminations, that are bonded by using adhesives to connect lamstock timber to make a continuous beam. The typical types of wood used include Douglas fir, western hemlock, and spruce and pine in BC. Since adhesives play a vital role in the connection, which leads to the strength, there is a lot of research in this field, which we will venture into. The main types of adhesives include the MUF, which is for indoor use, PRF and PU, which are used for outdoor use. Now we'll go into research on these adhesives. Previous research on 3 types of adhesives were done using 2 different moisture contents, at 12% moisture content, which is dry wood, and 22% moisture content, which is wet wood. These are figures 7 and 8 on this slide. We see that PU had the highest tensile strength, but the tensile strength was 40% greater at dry wood moisture content compared to wet wood moisture content. Now looking to the right of the slide, figure 9, this research looked at 2 out of the 3 adhesives, both outdoor adhesives, with respect to temperature. We see that at the 25 to 50 degree range, PU has higher Young's modulus, which is expected as seen in figure 7 and 8, but the PRS adhesive maintains a higher Young's modulus with increase in temperature, ranging from 50 to 150.
It's hard to talk about wood products without mentioning sustainability. As mentioned earlier in this presentation, wood is a carbon sink, unlike concrete and steel. This means that throughout its lifetime, wood absorbs ambient carbon from the atmosphere and stores it, which composes its structure. In Canada, wood is sustainably harvested, ensuring our forest's health, and as it's transported, it produces less GHG emissions due to its low weight compared to concrete or steel. In Canada, there are many incentives for engineers and builders to use wood as primary building products. As an engineer, we are taught that our products and services are supposed to be ethical and marketable, and sustainability is both of those. In recent years, many new governing bodies and certifications which add to the value of your building have entered the market. These services award points based on building practices, all of which promote wood over concrete and steel. Additionally, sustainable reforestation initiatives allow wood producers to offset their carbon emissions, allowing products to be produced with zero net emissions. To conclude, engineered timber products are favorable over typical products for many reasons. They have a high strength to weight ratio. There's a vast flexibility in member design, stunning aesthetics, and there's sustainability incentives and bonuses. We hope that you consider engineered timber products for your future designs. We now invite you to ask us any questions that you may have.